We can build this!
Calm down, Russ. Let's talk a little bit about OpenLMI.
Okay.
OpenLMI, the Open Linux Management Infrastructure, is an open source project that, entirely by coincidence, implements almost exactly that diagram that you created.
Okay, so far it sounds good.
So what it is an open source project that provides a powerful remote API for performing those low-level functions that we were talking about earlier.
Okay, so we're talking about something that's built around a management API. And what does that look like?
So, similar to the design you created before, what we have is a set of management agents on the system that perform low-level functionality. They can do things like making changes, monitoring the system, querying to see how it looks right now.
So they can do things like format a drive or set up a network interface?
Yep, that's correct.
Okay.
It also provides a standardized remote API in the form of XML over HTTPS, or specifically SIM WebM. It also provides a scripting environment based on Python and providing a CLI that can interact with the systems.
All right, that sounds like a really good start, and I see that there's a picture up on the screen, so let me guess. You're going to dive into the picture and explain the different parts of the system and how they work together.
Yes, I think a good place to start would actually be in the middle. So let's talk a little bit about the object broker. We use the OpenPegasus Symon, which manages the provider agents on the system. What it does is it pulls them in as a series of plugins and provides the remote API as well as an authentication and authorization layer for those capabilities.
Okay, so let me see if I understand this. We've got it's a communications core, which sort of sits in the middle, that talks to something that does the work and provides the interface to the outside world, and it handles all the communications, it handles all the authentication and security, and it's really the integration point for the rest of the system.
Right.
Okay.
So let's dig down a little bit and let's talk about the providers.
Okay.
The providers are there for doing the heavy lifting, performing the management operations that we need in order to accomplish a task. For example, formatting a drive or setting up a network bridge. It provides the OpenPegasus Symon with all of the functionality it needs to let the user actually perform those tasks.
Okay, so this is sort of the abstraction API that we were talking about earlier, built on top of the existing Linux tools and utilities, and providing a standard way of working with them.
Correct.
Okay, so far that sounds good. And is there more than just telling the system what to do?
Yes, the providers also offer a series of what we call indications, which are signals or notifications that something has happened on the system. For example, in the OpenLMI storage provider might be able to tell you, my RAID array has just failed one drive, so it is now operating in degraded mode, or a network interface has gone down.
Okay, so this is something that you don't want to be polling all of your servers, going, have you had a RAID drive failure? Have you had a RAID drive failure? Have you had a RAID drive failure?
Absolutely not. So what you would do is you would register a management console or a monitoring tool with the server to say, when such an event occurs, send me an indication.
Okay, so this would be used, we're talking about drive failures, so something occurs on the system that you want to know about failure, you would want to, and if you've got, for example, if a NIC goes down, you might want to have both the system administrator for that machine and the network operations people know about it. Right. So could you have that message, that event, going to multiple people?
Assuming that the network interface that failed wasn't the management interface?
Good point,
certainly.
Good point. And just looking at this sounds like it would be useful for things like long-running jobs. So if you're formatting a 4 terabyte drive, that's going to take a while. So you need to know when it's done, but you don't want to sit there looking, waiting for that stupid little indicator.
Right. The way the OpenLMI Symon works is when you start a long-term task, by default you are subscribed for the indication for that task's completion. So you would then you could then continue and go off and do whatever else you could do in parallel, and then you'd be notified when that operation completed.
This sounds like it could be really useful. So it would also work for something like users, so that if a user were added to a system, the system administrator and the security guy would both know about that account?
Yep.
All right, that sounds like it would be truly useful. Okay, what else do we have?
So now let's talk about the top level. Let's go up and talk about the clients.
That's my favorite part.
So there are several ways that we've put together the clients. We'll start from the lowest layer, which is the API itself. This is essentially SimXML. It's a very powerful, very complex low-level API that describes the system in an object model.
I was actually looking at this. This looks an awful lot like a library interface, that you've got a big box of commands, and there's a lot of them. You can do anything with it, but you got to dig into it a bit.
Yeah, that's exactly what it is. It's
okay.
A series of low-level APIs that we can use to then build the next layer of the system,
okay,
which is a series of LMI shell modules that are written in Python and that consume this API and turn it into something a little more user-friendly and a little easier to operate with.
Mm-hmm. And
this is
looking at the notes that says that this is a subset of the full API, so I would guess that this is taking the common, the routine thing, the things that I need to do, and it's giving me an easy way to do those?
Yes. And that is also the layer upon which we will build the CLI, which is actually using the LMI shell modules under the hood to provide us a friendly command line interface that is bash scriptable and provides a lower level of coverage, but probably covers the 80% case and certainly makes it easier to operate than the low-level tools.
Okay, so I like where I think this is going. So we've got the command line interface it's basically the stuff I'm going to be doing day in, day out, and it's simple and it's easy to use. And we've got the LMI scripts, which are written in Python, so you've got all the capabilities of the full Python environment, and you can work at that level. And then we've got the very low levels, which that's probably where you're going to be working, is that if you really need to do things in the system, you can drop down and work with it.
Exactly.
All right, now I'm kind of lazy. Are there scripts that exist for doing some of this stuff, or am I going to have to go out and start writing a whole bunch of Python from scratch?
So part of the OpenLMI project includes a series of contributed scripts that live in our upstream repositories that provide a starting point, a set of things that we believe are very common and that you would probably want to consume and modify, perhaps enhance, ideally contribute back, that really will bootstrap this process for the users.
Okay, so if I understand what you're saying here, there's a lot of the common stuff that's been done, but it's designed and intended to be extended and modified and customized, so it bootstraps me for doing my job, and it gives you the tool. It sounds like not only just gives you tools, it gives you a new toolbox that you can work with at the level you're working.
Yep.
I like it. And, okay. Sounds interesting. I'm going to have to ask you to show me what you're talking about.